In this video, we're going to talk about special segments in circles. So the length of line segments in circles. So what are we doing? We're going to look at chords, tangent, and secant lines in circles or on a circle if it's a tangent line. And we're going to find the lengths of the different segments that they're asking us to find. So we have two cases. We have a case where part or all of the line segment lies outside of the circle. And we have three different scenarios on how this can work. So we can have two secant lines, and we can have, which would be this case right here. We can have a tangent line and a secant line, and we can have two tangent lines. And this is the same scenario as when we're talking with angles, but now we're talking with just the line segments. So we're looking at the length of the line segments. So the formula is we're going to take the outside part of the line segment and multiply it by the length of the whole line segment. So I'm going to show you what I mean for each one. So, and in this case, you want to think of each line segment, you're going to multiply those pieces together. So I like to think of it, in this case, the left and the right line segment, because this is going to be the line segment on the left and this is going to be the line segment on the right. So for the line segment on the left, I'm going to take the outside part of the line segment, which is the part that's outside of the circle, and I'm going to multiply it by the whole length. And then I'm going to set that equal to the outside part of the right line segment multiplied by the whole length. Okay? For this middle scenario, the outside part of the line segment is this whole thing because the entire line segment is outside. Then I'm going to multiply it by the whole thing. Well, the whole thing also happens to be the part that's outside. So you're technically squaring that value, whatever it is. And you're going to set that equal to the outside part of the line segment multiplied by the length of the entire thing. On this third scenario right here, looks like an ice cream cone. These segments are always going to be equal because we're taking this value, whatever this is, and then we're squaring it because we're multiplying it by its same value. And we're going to set it equal to the outside part, which is the whole thing, times the whole thing. So basically, if you were thinking about this with numbers, if this was what you were trying to find, x, and this was equal to 5, you would take x times x equals 5 times 5. So you would get x squared equals 25. And the square root of 25 is 5. So you're not going to do any of these kinds of problems because the line segments of the tangent lines are always going to be equal. But know that that is an option of how you can set up this type of scenario with chords and line segments and tangents. So I have three examples for you. I have two like this middle guy, and one like this. The middle one has an easy version and a hard version, and I wanted to give you an example of both. So we're going to start with, though, the one on the left. So here's my first example. So we're going to draw in. You always want to draw in. I have to see everything that I'm doing. So I'm going to draw in. It says that Vy, so that's this whole thing here. I'm going to pick a color. This whole part is equal to 64. And VW, that's this whole part over here, also a good car, is equal to 40. And then VZ is equal to 12.8. And they want me to find XY. Okay, so I know the formula says, I'm going to call this X and I'm going to call this Y. Actually, just to be less confusing, I'm going to call this A and I'm going to call this B because the line segment is XY. I don't want to get confused with that. So I know that the formula says I take the outside multiplied by the whole thing. So I'm going to take the outside part of my top line segment. So I'm focusing in up here. Okay, so the outside part of my line segment is 12.8 times my whole line segment is 40. I don't care about this part right here, okay? I'm going to set that equal to the outside part of my line segment we called B, and I'm going to multiply it by the whole thing, which is 64. Okay, so now I'm going to draw a line down the middle, so whatever I do to one side, I do to the other, and I'm going to multiply. 12.8 times 40 is equal to 512. is equal to 64 times b. To get b on a side by itself, I'm going to divide both sides by 64. And I get b is equal to 8. Okay, if this value is equal to 8 here, they want me to find from here to here. So I know if this whole thing is equal to 64, then this value here is 64 minus 8, which is equal to 56. So xy is equal to 56. Okay, next one. Okay, again, our same formula. I'm going to take, first let's write in the numbers. So UG is 15. UC is 10. And find UD. Okay, so to find UD, I have to know what this is. So I'm going to take my outside. I'm going to start with this side over here, this UG side. So my outside part is 15. Multiplied by my whole line segment is also 15. And I'm going to set that equal to my outside part, which is 10. Now I'm working over here. Here, I'll change the color. So, whoops. I will change this color. Outside part is 10. And my whole line segment, I'm going to add these together, is going to be 10 plus x. Okay, so now I multiply. 15 times 15 is 225. And I'm going to distribute with this 10 here like this. So 10 times 10 is 100 plus 10x. To get x on a side by itself, first I have to subtract 100 from both sides. So I get 125 is equal to 10x. And to get x on a side by itself, I'm going to divide both sides by 10. Oops. So I get 12.5 is equal to x. Okay, and they wanted me to find UD. So if this part right here is 12.5, then to go all the way from U to D, I have to add them together. So UD is equal to 10 plus 12.5 or 22.5. So be very careful what they're asking you to find, because sometimes they might just ask you to find the value of x, or in this case, CD, the line segment, but they wanted you to find the whole thing. So you have to go back and do that one extra step. So be very careful of what they want you to find. Okay, here's the hard one. You'll see why this is hard in a second. So the setup is the same. So I'm going to write down all my values. So PQ is equal to 12 and SR is equal to 10. Find QR. Okay, so this I don't know. All right, so my setup says on my left-hand side, I'm going to take my outside times my whole thing is equal to my outside, which is x, times my whole thing. I add them together, x plus 10. All right, so I multiply these out. I get 144 is equal to, distribute this, x times x is x squared, and x times 10 is 10x. Okay, now I have an x squared. Here's where all that algebra comes back. You either have to factor or use the quadratic formula. Either way, you have to set your equation equal to 0. So I'm going to subtract 144 from both sides. So I get x squared plus 10x minus 144. Okay. I'm going to do this both ways, so this is going to take a little bit longer because I want to show you both ways in order to solve this. Me personally, if I don't know the factors of negative 144 that add up to 10, so two numbers that multiply to negative 144 that add up to 10, like kind of right off the bat, I'm probably going to use the quadratic formula. So that's how I'm going to start this one off. Okay, I'm going to start with the quadratic formula. So the quadratic formula says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now my a, my b, and my c come from my equation, so my a value is the number that's next to my x squared, my coefficient. My b value is the number that's in front of my x, and my c value is my constant. And I'm going to plug these numbers in. So I get x equals negative b, so negative 10 plus or minus the square root of 10 squared minus 4 times a, which is 1, times c, negative 144. All divided by 2 times a, which is 1. I'm going to simplify inside my square root first. Plus or minus the square root. Okay, so I get 100. Negative 4 times 1 times negative 144 is a positive number, so this is going to turn into a plus because a negative times a negative is a positive. And 4 times 144 is 576, all divided by 2. I keep simplifying inside, so I get negative 10 plus or minus the square root of 676, all divided by 2. Then I take the square root of 676, and that gives me 26. Oh, that's a nice, neat number. That's good. So I have negative 10 plus or minus 26, all divided by 2. Okay, and then I have to figure out my two answers. So my two answers are negative 10 plus 26 divided by 2, and negative 10 minus 26 divided by 2. So negative 10 plus 26 is going to give me 16 divided by 2, which is 8. So there's one answer. And then negative 10 minus 26 is going to be negative 36 divided by 2. And negative 36 divided by 2 is negative 18. Okay, so does it make sense to have a negative length for a line segment? No. So this 8 would be my only answer. So this is equal to 8. Okay. Now, I do want to show you how to do this by factoring also. So I'm going to draw a line here down the middle. And this was the quadratic formula. And this way I'm going to factor. Okay, so when we're factoring, I want to know what two numbers multiply to negative 144 that add to 10. Okay, so I'm going to write out my factors of 144. Now, because I want to multiply by negative, or I want a negative 144, then one of my numbers has to be positive and one of them has to be negative. So I'm going to start with my easy ones. So 1 times 144, where one of them is positive and one of them is negative. And I have to take both into consideration each time. So every time I have a pair of numbers, it's actually going to give me two pairs because each one has to be positive and negative. Okay, so 144 divided by 2. Yes, so 2 times 72. So I'm going to write them twice where each one is negative. Okay? 144 divided by 3. So 3 times 48. And negative, negative. Okay? 144 divided by 4, that's 36. So I got 4 and 36. 4 and 36. All right. 144 is not divisible by 5. It is divisible by 6. So I have 6 times 24. Negative, negative. It's not divisible by 7. It is divisible by 8. So I have 8 and 18. Negative, negative. And it is also divisible by 9. 9 times 16. Negative and negative. And it's not divisible by 10 or 11, but it is divisible by 12. And 12 is the only one where I have a pair because they're the same number. Okay, that's a lot of factors. Now, out of all these factors, which numbers, remember, we're trying to add up to 10. Which two numbers add up to positive 10? Right here. So that means that your factors are going to be x minus 8 and x plus 18. equals 0. Now you have to take each group. I'm going to zoom this in because I'm going to run out of space otherwise. You have to take each group and set it equal to 0. So x minus 8 equals 0. Solve. I'm going to add 8 to both sides. So I get x is equal to 8. And then over here, x plus 18 is equal to 0. Solve. Subtract 18 from both sides. X equals negative 18. Now, you're going to ask yourself the same question. Does it make sense for you to have a negative answer, a negative segment length? No. So your answer here is going to be 8. It doesn't matter which way you do this. You can use the quadratic formula or you can factor. You'll see you get the same answer both ways. Again, like I said, this was the hard one, but I wanted to give you an example so that you can see how this works when it gets a little bit more involved with the math. Okay. Case 2, if we're moving on. So now I'm going to have all my segments that are going to lie inside the circle. This is probably the easiest of all of the cases and all of the problems in here. So what we're going to do is we're going to take each line segment in the circle. So this is what it would look like. And I'm just going to take like the left line segment. In this case, I'm calling it this guy right here. And see how it's split up into two parts where there's a point of intersection? I'm just going to take each part and I'm going to multiply it by each other. And then I'm going to set it equal to this line segment over here. And I'm going to take each part and multiply it by each other. So if I come down here, here's my example. So I'm going to fill in my numbers. So it says that EN is 33. So this one's 33. EK is 16.5 here. EJ is 22. Find MN. Okay, so they want me to find the whole line segment, but in order to do that, I need to find this value here. So I take each of my parts of my line. So I'm going to start with this left line here. And I'm going to multiply, we'll pick a different color. This left line here, and I'm going to multiply my two values. I'm going to multiply 22 times 16.5. I'm going to set it equal to this green line over here, each part. So 33 times x. And I'm going to solve. Line down the middle, multiply 22 times 16.5 is equal to 363. Is equal to 33x. To get x on a side by itself, I'm going to divide both sides by 33. And I get x is equal to 11. Okay, so if this is equal to 11, they want me to find MN. MN is this whole line segment right here. So together I have to say, well, 33 plus 11 is equal to 44. And that's my value for MN. So again, just be careful what line segment they're asking you to find. Some problems might only ask you to find EM, which is the value we had x, and then the answer would just be 11. But some you're going to have to go that one step further to find the whole segment or the part that they're asking you for. So just pay attention to that. Good luck and let me know if you have any questions.